Okay, for the prior two problems are manipulative, and certainly I don't like manipulating too much, but number 12 is a word problem, and it says, in how many different ways can $7.15 be paid with 50-cent pieces, 25-cent pieces, and 20-cent pieces, so that twice the number of 50-cent pieces plus twice the number of 20-cent pieces shall exceed the number, oh boy, this is a lot of work. Let's go to the whiteboard, and I'll start to write this down. But again, you want to maintain the problem. I'll have the problem written on a piece of paper, so I can just read it, all right? So let me go here, go back to my whiteboard, and I need to, realize I've got some integer variables over here. And let me just go through that with you. And what I'm going to say is, I'm going to say x equals, it's the number of 50-cent pieces. So I'm just going to put down 50-cent pieces, like this over here. It's the number of 50-cent pieces. And then I'm going to say y is the number of, let me put a little circle on it so it looks like a coin. So y is the number of 25-cent pieces. And again, I'll make them look like coins. And then z is the number of, and that's going to be 20-cent pieces. By the way, I prefer to use cents. So I want to go back and understand that for every x I have 50 cents, for every y I've got 25 cents, and for every z I've got 20 cents. And I want to point out that x, y, and z, they have to be positive integers, by the way. All right? They can't be negative numbers. So what I want to do is start talking about the very first thing they said about it. And the very first thing they said, and they've got $7.15 in a payment. All right? So I'm going to say, if I have $7.15, well, every x gives me 50, every y gives me 25, and every z gives me 20. And what would that equal? That equals $7.15. All right, I'm looking at that, and I'm honest with you, I want to reduce the size of those numbers. And one way you could do it is divide through by 5. So let's put this down. You get 10x plus 5y plus 4z equals, I'm dividing by 5, right? So let's take a look at that. 5 goes into 7.15. 1, that's going to give you 5. 21, that's going to give you 4. That's 20. And 1 and 5, that's 3. So 143. All right, that's not so bad. All right, let me get my eraser out. I'm going to start to erase things I don't need anymore. Get rid of my baby arithmetic. I'm kind of delaying the inevitable. Continue to read, right? I don't remember what I read. But let's see. Let me see. 10x, 5, 4, 143. Let me just check that again. 5 times 143 is 500, 700. Yeah, 715. Not bad. All right, let me keep reading it. It says over here, again, 50-cent pieces, 25-cent pieces, 20-cent pieces. So that twice the number of 50-cent pieces, let me put that down. Twice the number of 50-cent pieces, and again, all I'm doing is reading over here. So twice the number of 50-cent pieces plus the number of, twice the number of 50-cent pieces plus twice the number of 20-cent pieces? Yeah, 2 Z's. Again, all I can do is keep reading it. Word soup almost. Shall exceed the number of 25-cent pieces by 31. So it's going to be y plus 31. All right? So I'm looking at this, and I'm wondering what to do about that. And I got 2 equations, 3 unknowns. And by the way, I know they're all integers. And what I'm trying to do is try to, maybe reduce the complexity of the problem by getting rid of one of the letters. And what letter could I get rid of? I think I want to get rid of the y's. So what I'm going to do is over here, I'm going to say, I'll take this equation here and write down y equals 2x plus 2z minus 31 is equal to y. And then I'm going to take this thing here, I'm going to plug it in up here. Let me write this down for you. You get 10x plus 5. And let's write that down. It's going to be 2x plus 2z minus 31. All right, plus 4z equals 143. All right, let's take a look. One step at a time, right? And what do you get here? You get 10x plus 10x plus 10z minus 155 plus 4z equals 143. I'm going to keep simplifying it. You get 20x, 14z, and I'm going to do 143 and 155 and add them together. That's 892, 298. I'm going to divide by 2, just to make it easier for me. What do you get? Let's see, 2 into 20x, that's 10x, plus 7, whoops, I got excited there, 7z equals, well, 2 into 298, that doesn't look bad. Write down for you though, 1, 2, 9, 4, that's 8, 1, 8, 9, 149. All right, here comes the problem, by the way. You may even forget why you're doing this over here. You're trying to get an integer solution to the problem, by the way. And certainly I'm going to claim there, certainly could be more than one. I'm not saying there's not, but I want to see if I can maybe solve this thing for the letter z. So I'm going to say 7z equals 149 minus 10x over, not over yet, I didn't do that yet. You see if we did that, okay. Yeah, and then you're going to divide both sides by 7. So z equals, all right, here comes the tough part. And I got triples. I got x, I got y, and I got z. I want to point out that x, y, and z have to be positive numbers, right? There's no way I could do this otherwise. So what I'm going to do over here is just, kind of run through it and look, I'm sorry, this is 10x, and try to come up with numbers that, for x, that I could actually figure out. And I'm looking at it, and I'm really looking for an x value that when I plug it in, that it would divide by 7. So the first one I see actually is 10. And again, stop me. I always say stop me if I go too quickly, right? And you can always pause the tape, by the way. So I'm going to write, when I say 10, I'm seeing 49 then. So 149, 10 times 10 is 100. And now I get 49, and 49 by 7, right? What's 49 divided by 7? That's going to be 7. So z is 7 there. And I see that immediately, right? I'm not saying there's not another one. I'm just seeing that immediately. Now, the question is, I know what x is, and I know what z is, but is there some expression for me to come up with the y in the middle? And there is. And someone says, where is that expression? I think it's right over here. All right? So it's going to be, let's see, twice the x, which is 20, plus twice the z, which is 14, and then minus 31, and that would be equal to the y, right? So that's 34 minus 31, which is 3, all right? So 10, 3, 7. All right, the question is there another one? And I'm looking at this thing, and I'm really looking at the multiples of 7. Let me get my eraser out, by the way. I'm going to erase this over here. And again, I'm looking for multiples of 7. Erase this. I'm going to erase my baby arithmetic too, by the way. And integers are always difficult to deal with, but multiples of 7. And kind of looking at it, I certainly know the multiples of 7. And let me write some down for you, all right? So, you know, 7's certainly one of them. 14. You get the idea, right? 21. So really what I'm looking for is I'm looking for a number taken from 149 that would make it a multiple of 7. And I got to only do with positive numbers, by the way. So I really want to, sort of like saying you could start. You can't have a negative number, by the way. If you tried 1, let me point out what I mean by that. I'd get 139, right? Now looking at 139, that's not divisible by 7. I'm going to say that's not working out. Let me try 2, and you get 129. Well, that's not divisible by 7 either. Let me try 3, and what do you get? 149, that would be 119, right? Now, was 119 divisible by 7? And I say yes. So 7 into 119. Well, what are you going to get there? You get 1, 7, and then you can get, let's see, 49, right? Yeah, 17. All right? So I'm going to say if the x is 3, you're going to get 17 for the z. All right? Again, we're just playing around with some numbers over here. So what else do you get over here? Let's take a look. I'll go back up here. That's going to be 6 plus 2 times 7 is going to be 34 minus 31 would equal what y is. That's going to be 49, right? All right. So I think I have my answers over here. You may wonder if there's other values over here, but you're very restrictive in what you can pick for x, by the way. For example, the x could be 1, 2, 3, 4, yada, yada, yada. What's the biggest could be? I'm going to say 14. And why is that? That would be 140. You couldn't go to 15, by the way. It's a very limited set of numbers to choose, by the way. But I believe these are the only 2 that are going to work right now. All right? You can check the other ones if you want, by the way. And we're done. Thank you.